Alrighty, in this video, we are going to be looking at how to integrate 2 to the x, and then we'll just use the rule from now on whenever we figure out how to do that. Now it says we want to convert 2 to the x to base e, and then we want to use substitution to integrate. So here's the thing. I want a base 2 to be a base of e. So I'm going to have e to the something, and that's going to give me base 2. Now, remember, using my properties, ln and e are inverses of each other. So what I'm going to do here is just plop an ln right here and plop a 2 next to it so that the e and ln cancels out because they're inverses of each other. And then that's going to be left with 2 as my base, and then we still have x as my exponent, which is what we want right here. So now that we have e to the ln of 2 times x using base e, I'm going to go ahead and use substitution by letting u be ln of 2 times x, which means that du is just going to be ln of 2 dx. Now, if that's the case, I'm going to have 1 over ln of 2 e to the u du. I'm going to integrate e to the u, and that's just going to be e to the u. So now I have 1 over ln of 2 e to the u plus c. And I know that u is ln of 2 times x. So now I have 1 over ln of 2 times e to the ln of 2 times x. And remember from earlier, we know that e and ln are inverses of each other, so they cancel out, meaning that I have 1 over ln of 2 times 2 to the x plus c. Interesting. So this tells us that if I wanted to take the integral of, let's say, a to the x, I'm going to have 1 over ln of a, whatever my base is, times a to the x plus c. And that's going to be my little formula that you'll need to remember. Now, using u sub, that's going to be a little bit, not u sub, chain. You're going to see that if I have chainlet number 10, it's going to be very, very similar. Now, in order for us to have chain, obviously, we're going to have to find some sort of derivative in my function. So for number 10, we are going to convert 3 to the x to base e, just like what we did with number 9 here. So I'm going to have e to the ln of 3 times sine of x cosine of x dx. That way, if I were to simplify e to the ln of 3, I get 3 sine of x cosine of x dx, which is what we want. All right, so now I'm going to set u to be my exponent, so ln of 3 times sine of x, which means that du is going to be ln of 3 cosine of x dx, which should be a good reference because now your cosines are going to cancel out. And then you're just left with 1 over ln of 3 e to the u du. Now, we know that the integral of e to the u is just e to the u, and substituting u to be ln of 3 sine of x is going to give me this lovely thing right here. And we know that e and ln are inverses of each other, so I could get rid of her. That's going to give me 1 over ln of 3 times 3 to the sine x plus c, which is what the original function was right here. So this means that if I have a to the u to the x times u prime of x, where u prime of x is going to be my derivative, I'm going to have 1 over ln of a times a to the u of x, given that u of x is our function. All right, so let's look at 11 and 12. Looking at number 11 here, I'm going to set u to be 3 minus x squared, and du to be 2 3 minus x dx. Don't forget about the -1 using chain. So you get this lovely thing right here. The 3 minus 6 will cancel out. That's great. So that means that I'm left with a -1/2. And then I have 7 to the u du. Now, based off of number 9 here, we know that the integral of a to the x is going to be 1 over ln of a times a to the x. So the integral of 7 to the u is going to be 1 over ln of 7 times 7 to the u plus c. And we know that u is 3 minus x squared. And this would be my antiderivative right here. So -1/2 times ln, -1/2 times 1 over ln of 7 times 7 to the 3 minus x squared. Lots of fun. All right, for number 12, we have a definite integral. We have 6 to the x and we have 2 to the x, so we know what the derivative, not the derivative, the antiderivative of that, hopefully, is by using our little formula. So we have 1 over ln of 6 times 6 to the x minus 1 over ln of 2 times 2 to the x. And then my bounds are going to be from 1 to e. I'm going to plug in everything I know now. So I'm going to have 6 to the e ln of 6 minus 2 to the e ln of 2 minus 6 over ln of 6 minus 2 ln of 2, and call it a day. Just leave it like this. If you want to be fancy and simplify like this right here, you can. However, we know that it's better to not simplify because you're going to lose the answer point if you simplify incorrectly. So just keep it like that and call it a day. All right, so let's look at something like number 17, where we have 3 to the 2x over 1 plus 3 to the 2x. I'm going to set u to be my denominator. Du is going to be, okay, now remember du is going to be my derivative. So this one's going to be ln of 3 times 3 to the 2x times 2 dx. And I know this kind of looks weird, but the 3 to the 2x will cancel out, meaning that my ln of 3 and my 2 will be in the denominator. So I have 1 over 2 ln of 3. And then I have the integral from of 1 over u du. So then I have ln of u plus c. Now u is 1 plus 3 to the 2x, and once again, that thing right there is always going to be positive, so I'm not going to have absolute value bars. So I have 1 over 2 ln of 3 times ln of 1 plus 3 to the 2x. If you want absolute value bars to, be safe, you can. But, I'm just going to keep her like that and call it a day. All right, same thing for number 18 here. I'm going to think about what my u should be, whether it is negative 1 over t or t square. Now, if I set u to be t square, I'm going to have du to be 2t dt. Unfortunately, I can't do anything with this right here because this is t to the negative 1 over t. So, can't really choose u to be that, even though, t squared is in the denominator. And we usually check the denominator first. Instead, remember, look inside of a function to see if something works. So let's say negative 1 over t, because then the derivative is going to be 1 over t squared dt. And then if I were to do that, the t squared here and the t squared here is going to cancel out, which means that I am left with 2 to the u du. And I know that the antiderivative of that is going to be 1 over ln of 2 times 2 to the u plus c. And I know that u is negative 1 over t. So this right here is going to be my antiderivative. All right, so you should be able to do 19 and 20. Those definite integrals aren't too bad. 19, you're going to have to use u sub. 20, you are just going to have to use the formula and call it a day and see what happens there. And of course, you could do 13 and 14. In class, we are going to be doing some application problems. So in class, we're going to have lots of analysis.